All right, so welcome to our deep dive. And today we're going to be tackling the anthropic principle.
Yeah, it's a really fascinating area
It is.
where physics and philosophy, they kind of collide.
They really do. It's one of those real head scratchers. And we're going to try to make it, I think, as approachable as possible, but be warned. Things are going to get pretty mind-bending today.
Yeah, and hopefully fun
Oh, absolutely.
at the same time.
Yeah.
So we're essentially trying to answer the question, why is the universe the way it is? And why does it seem so perfectly suited for life as we know it?
Yeah, that's the big question. And, whenever we're talking about the anthropic principle, we kind of have to think about the two sort of main flavors.
Right.
We have the weak anthropic principle, or WP, and then we have the strong anthropic principle, or SAP.
Yeah.
And, WAP is kind of like the less controversial cousin.
Right.
Right. It's a little bit more scientifically grounded, whereas SAP, that's the one that really gets people talking.
Yeah, it's definitely the more speculative one, that's for sure.
It is.
But it's also, I think, the one that has more thought-provoking implications.
Yeah, it's the one that keeps you up at night.
Exactly.
Right.
Yeah.
So let's start with that less controversial one.
Okay.
Let's start with the weak anthropic principle.
Right.
What is that all about?
Sure. So the weak anthropic principle essentially says that the universe that we observe has to be compatible with our existence because, well, we're here to observe it.
Right. Because if it wasn't, we wouldn't be here talking about it.
Exactly.
So it's kind of like, of course the fish thinks the ocean is perfect for swimming.
Right. Right.
Because if it wasn't, there would be no fish to think about it.
Exactly. It's a bit of a tautology, but it has some pretty profound implications when you start thinking about it.
It really does. So it's all about this idea of selection bias, right?
Mhm.
We're only seeing the universe from our limited perspective.
Precisely.
As beings that exist. We're not necessarily seeing the whole picture, just the parts that are compatible with us being here.
That's right.
But how does this play out in actual scientific observations? What kind of examples are we talking about?
Sure. So one of the best examples comes from astrophysics. Frank Tipler uses this example of measuring galaxy brightness. We tend to observe brighter galaxies simply because they're easier to see, right? Our observations are inherently biased towards what we can detect.
So our existence is like this filter shaping how we perceive the universe.
Exactly.
It's like, if you're trying to understand human history, but you only interview people who are over 100 years old,
Right.
you're going to get a very specific...
Very skewed perspective.
Yeah.
Yeah.
Okay, so that's kind of a way to wrap your head around it. You mentioned this guy, Frank Tippler.
Yeah.
A lot of what we're talking about is going to be dealing with his work. Who is he, and why is he such a key player when we're talking about the anthropic principle?
Yeah, Frank Tippler is a mathematical physicist and cosmologist, and he's one of the leading proponents of the anthropic principle, particularly the strong anthropic principle. He's written extensively about it and really explored the implications of what it would mean if the universe is truly fine-tuned for life.
All right, so we're going to be drawing a lot on his work. Now, you mentioned another example from Tippler
Yes.
that really highlights this weak anthropic principle, something called the Dicke relation.
Right.
Okay, what in the world is the Dicke-Wheeler relation?
The Dicke-Wheeler relation, it basically connects the age of the universe to fundamental constants like the gravitational constant and these timescales that are related to particle interaction. So the strong interaction timescale, for example. And there's no obvious reason why these things should be linked, yet they are.
So you're saying that the age of the universe is somehow tied to these really fundamental constants
Yes.
that determine how physics works at the smallest level?
Exactly. And this has profound implications for the possibility of life.
Okay, so this sounds like something we should definitely unpack a little bit. Why is this connection between the age of the universe and these fundamental constants so important for the existence of life?
Well, the key is to understand how elements form. So the heavier elements that are essential for life, like carbon, oxygen, nitrogen, these are all forged in the hearts of stars.
Okay.
Right? And these processes, they take time, a lot of time. And the time it takes for these elements to form is actually determined by those fundamental constants and the particle timescales we mentioned earlier. So the Dicke-Wheeler relation is telling us that the age of the universe is kind of directly tied to the possibility of our existence.
So it's almost like the universe had to be a certain age, had to wait a certain amount of time before life like ours could emerge.
Exactly.
Like it had to set the table before inviting us to dinner.
Exactly. Yeah, that's a great analogy.
But does this mean that our existence was somehow planned? That there's some grand design at play?
Well, that's where things get a little bit more slippery, and we start wading into the territory of the strong anthropic principle.
Okay, so we're going to be wading into those waters, but I think for now, we've given our listeners a lot to ponder about, just with this weak anthropic principle.
Absolutely.
And how our very existence might be shaping how we see the universe.
Yeah, I think that's a great starting point for our discussion.
And it's just the tip of the iceberg, so stay tuned as we dive even deeper
Definitely.
into the anthropic principle.
So we've kind of laid the groundwork there with the weak anthropic principle,
Right.
which deals with that observational bias. Now let's step into the more speculative realm of the strong anthropic principle, or SAP.
All right, let's dive into those murky waters. I have to admit, the idea that life might not just be a cosmic accident, but somehow essential to the universe is, well, it's a little intimidating.
Yeah.
But it's also intriguing.
It's definitely a thought-provoking idea.
It is.
But before we get carried away, I think it's important to emphasize that SAP is not really a scientific principle in the same way that WAP is.
Okay.
It's more like a...
So we're moving away from hard science and more into the philosophical speculation realm?
I think that's a good way to put it. Even Brandon Carter, who coined the term, he preferred to call it the strong anthropic proposal rather than principle. So yeah, we're definitely entering the realm of speculation.
But even so, it's worth exploring.
Oh, absolutely.
Right. What are we talking about when we talk about the strong anthropic principle? What are some of the key ideas behind it?
Well, essentially what it suggests is that the universe is fine-tuned for life, and not just in the sense that, the conditions happen to be right, but that life actually plays a fundamental role in the universe's existence or purpose.
So it's not just that we're lucky to be here, but that we're here for a reason.
That's one way to put it, although needs might be a little bit too strong of a word. It's more like, we're part of a grand cosmic puzzle, and our existence kind of helps complete the picture in some way.
I could see how that would appeal to our human desire for meaning and purpose.
Mm-hmm.
But let's be honest, it also sounds a little bit like wishful thinking.
Right.
What kind of evidence is there to support this idea?
Well, that's where things get tricky because there's no direct, empirical evidence for SAP in the same way we have evidence for, physical laws like gravity.
Okay.
It's more about interpreting the existing evidence in a new light and considering the possibility that maybe our current understanding of the universe is incomplete.
So more of a philosophical framework than a testable scientific theory.
Exactly, yeah. And it faces a number of challenges. For example, as Frank Tipler points out, there's really no evidence to suggest that intelligence plays any significant role in the universe's workings today.
Wait, yeah. As far as we can tell, it seems to be chugging along just fine without us pondering its mysteries.
Exactly. So, that's one of the big challenges. But then again, maybe our significance is yet to be revealed.
Yeah, maybe we're just at the beginning of this long cosmic story.
Right.
And our role will become clearer as the universe continues to evolve.
That's a possibility. And this kind of leads us to an even bolder proposition, which is the final anthropic principle.
Oh,
or FAP.
FAP, okay. We're escalating quickly here.
We are, yeah.
From the strong anthropic principle to the final anthropic principle.
Wow.
What's that all about?
So FAP takes this idea of life's importance to the extreme. It proposes that the universe is structured in such a way that intelligence in some form will not only exist, but will persist forever.
Okay, hold on a second. We're talking about eternal life here, like some kind of cosmic afterlife.
No, it's not really about, spiritual realms or reincarnation or anything like that. FAP is grounded in the idea that intelligence as a process of information processing, of problem solving, is actually an inherent feature of the universe. And that this process will continue indefinitely, even as the universe itself undergoes, dramatic transformations.
So it's like even as stars die out and everything cools down to absolute zero, there's still this intelligence persisting somehow.
Exactly.
That's a mind-blowing concept.
It is.
But how does that even work? I mean, how do you reconcile that with our current understanding of physics?
Well, that's the million-dollar question. And proponents of FAP, like Frank Tipler, they explore the intersection of physics, cosmology, information theory, to try to propose scenarios where intelligence could persist even in the face of, seemingly insurmountable challenges.
Okay, well, we've got to dig into this. Let's go down that rabbit hole. What are some of the scenarios that they've come up with?
Let's start with one of the most fascinating and controversial interpretations of FAP, which is Tipler's omega point theory. So this theory suggests that the universe will eventually evolve toward a final state called the omega point, which represents the culmination of all information processing and intelligence.
So it's like the universe is gradually becoming a giant cosmic brain.
That's a pretty good analogy. But before we get too carried away with the big picture, let's break down some of the key ideas behind Tipler's theory.
Yeah, let's get into some of the nuts and bolts here.
Okay, so one of the most fundamental ideas is Tipler's redefinition of life.
Okay.
He argues that life should be viewed not just as, biological organisms, but as any system that processes information and is subject to natural selection.
So instead of focusing on, like, carbon-based life forms.
Exactly.
We're looking at this underlying process of information processing as the essence of life.
Right. And this opens up the possibility for life to exist in forms that we might not even recognize. For Tippler, even a sufficiently advanced computer program could be considered a form of life if it meets these criteria.
So we're really blurring the lines here between the biological and the artificial.
We are, yeah. We're exploring the fringes of theoretical physics and cosmology, where our current understanding really starts to break down, and we have to consider, some pretty radical new ideas.
Okay, I'm all for pushing the boundaries of thought here. So if life is essentially information processing, how does that play into this omega point theory? How does this process continue indefinitely as the universe evolves and changes?
Well, that's where Tippler gets really creative. He combines insights from thermodynamics, from general relativity, even quantum mechanics.
Wow.
To propose a scenario where the universe, even if it's finite in size and lifespan, could still support an infinite amount of information processing.
All right. How do you cram an infinite amount of information into a finite system? Doesn't that violate, like, some fundamental laws of physics?
Well, that's the million-dollar question. And Tippler's answer involves some pretty mind-bending concepts, like the manipulation of energy and temperature to maximize information storage and processing, and the idea that subjective time, as experienced by intelligent beings, could be very different from the objective time of the universe as a whole.
All right, we're getting into some territory here where my brain is starting to feel a little overloaded.
Yeah.
Can we break down some of those concepts and kind of explore how they might actually work?
Absolutely. So let's start by looking at the role of energy and temperature in information processing.
Okay.
So as you know, energy is required to store and process information. But the amount of energy that's needed per bit of information is actually inversely proportional to temperature.
So the colder something is, the less energy it takes to store information.
Exactly. And Tippler argues that a sufficiently advanced civilization could actually manipulate energy and temperature in such a way as to allow for near infinite information processing, even in a universe that's, gradually cooling down.
So it's like this cosmic energy management problem. You got to figure out how to make the most of the available resources to sustain this eternal information processing.
Precisely. But there's another piece to this puzzle, which is the structure of the universe itself. Tippler argues that for this to work, the universe has to be closed.
Closed. So like a sphere with a finite size.
Exactly. Because an open or flat universe, one that expands forever, that poses a problem for communication. Because as the universe expands, the distance between objects increases, and redshift stretches the wavelengths of light, making it harder and harder for information to travel.
So it's like you have these little pockets of information processing, but they're drifting further and further apart.
Right. They're becoming isolated.
Unable to communicate with each other.
Exactly. But in a closed universe, the expansion eventually reverses and everything starts to collapse back in on itself. And this collapse, Tippler argues, could actually provide the energy that's needed to sustain this information processing at an accelerating rate.
So the universe's eventual demise can actually fuel this ultimate flourishing of intelligence.
That's the basic idea, but there are still some major hurdles to overcome. For example, Even in a typical closed universe, you still have these things called event horizons,
Okay.
which are boundaries beyond which communication becomes impossible.
So even in a closed universe, you could still end up with these isolated pockets
Right.
of information that
Exactly.
can't connect with each other.
But there's a special type of closed universe, one that avoids these event horizons.
Okay.
And in this type of universe, all world lines, which represent the paths of objects through space-time, they remain in causal contact for all time.
So every point in the universe can potentially communicate with every other point, even as it collapses.
That's the idea. And this brings us to a key concept in Tipler's theory, which is the C boundary.
C boundary. All right, now we're getting into some real Star Trek terminology here.
We are, yeah. So imagine the universe as a map, right?
Okay.
The C boundary is like the edge of that map, the ultimate limit of space and time. It's where time, as we understand it, ends.
So it's like the end point of the universe's journey.
In a way, yes. And in these special closed universes where all world lines stay connected, the C boundary actually consists of a single point.
Okay.
And this point is what Tippler calls the omega point.
So all paths in space-time lead to this omega point.
Exactly.
It's like the universe's grand finale where everything comes together.
That's one way to think about it. But the omega point is more than just an ending. It's also a beginning, a point of infinite density, infinite complexity,
Right.
where all information is ultimately stored and processed.
It's like the universe's grand finale is also its ultimate backup system, right?
Exactly.
Preserving everything that ever was.
Right. And this is where things get even more mind-bending. Because the omega point encompasses all of space-time, it kind of experiences all of history simultaneously.
Wow.
Just like we experience, events on our past light cone as simultaneous.
Right.
We see the person in the room with us in the Andromeda Galaxy as simultaneous, even though the light from Andromeda took millions of years to reach us.
Right. Right. So it's like the universe's ultimate time-lapse video playing out in its entirety at this omega point. It's incredible to think that all those moments, all those experiences wouldn't just be lost.
Right.
But somehow preserved.
Exactly.
But how do we even begin to reconcile this with our current understanding of physics? I mean, this all sounds incredibly speculative, even for, a theoretical physicist.
You're not wrong. The omega point theory, as fascinating as it is highly speculative. It's not widely accepted within the scientific community, but it does, push the boundaries of our imagination and challenges us to consider these possibilities that might seem impossible at first glance.
Okay, I think my brain needs a little bit of a break after that deep dive into the omega point.
Yeah.
But before we move on, I have to ask, is there any way to test this theory? Or is this purely a philosophical thought experiment?
That's a great question. And we'll explore some of the testable predictions of the omega point theory and delve into those philosophical implications as we continue our deep dive into the anthropic principle.
All right, so we've really gone down the rabbit hole here.
We have.
With this omega point theory.
Deep down.
And even if it's highly speculative, it really does raise some profound questions.
It does.
About the nature of reality, consciousness, even the possibility of some kind of cosmic purpose.
Yeah, absolutely. I mean, the omega point theory, it's almost like a philosophical springboard.
Yeah.
It kind of launches us into this realm of thought where the boundaries between science, philosophy, even spirituality start to blur.
They really do. And I think that's what makes the anthropic principle in general so compelling.
Yeah.
It forces us to confront these big existential questions that we might otherwise just shy away from.
It really does.
So let's kind of dive into some of those deeper philosophical waters here.
Okay.
One of the most intriguing aspects of the omega point theory is its implications for the future of intelligence.
Right.
If the universe is indeed evolving toward this final state of ultimate complexity and intelligence, what does that mean for us?
Yeah.
And for any other intelligent beings out there?
Well, that's a great question. In Tippler, he talks about eternal progress as being a key feature of this omega point scenario.
Right.
So what does he mean by that? Well, he envisions a future where knowledge, technology, ethical development, they all continue to advance indefinitely, driven by this ever-increasing complexity of information processing. So it's a vision of a universe that's constantly learning, growing, expanding its understanding of itself.
Okay, that does sound pretty optimistic. almost utopian in a way. But isn't there a bit of a paradox there? Because if the universe is converging towards this final state, the omega point,
right,
wouldn't that imply an eventual end to progress?
That's a great point. And Tipler actually addresses this by emphasizing that that this eternal progress, it doesn't really apply to specific species or civilizations. In fact, he argues that it's logically necessary for individual species like us humans to eventually become extinct.
Yeah, die.
If this eternal progress is going to continue.
Okay, that doesn't sound very comforting.
Well, it's a challenging concept, but his reasoning is that each species has inherent limitations. Our brains can only hold so much information.
Right.
Our bodies can only withstand certain conditions.
Yeah.
And to truly achieve this eternal progress, intelligence needs to constantly evolve, transcend its current limitations, and kind of emerge in new forms.
So it's like a cosmic relay race in a way. Like each species is carrying the torch of intelligence for a while,
right,
before passing it on to the next generation. And this process continues all the way to this omega point, where intelligence reaches its ultimate potential.
Yeah, that's a great analogy, and it actually leads to another fascinating aspect of the omega point theory, which is the possibility of individual resurrection.
Okay, hold on. Resurrection. How did we go from physics to resurrection?
Well, it comes back to this idea of the omega point's ability to access information from all points in space-time. Right. So Tippler argues that the beings at the omega point, or even advanced civilizations existing before the omega point, would have the computational power to create these incredibly detailed simulations of past individuals based on information that they've gleaned from the universe's history.
So it's like they're recreating entire lives, personalities, memories, everything that made a person unique.
No.
But would these simulated individuals, would they be truly alive? Would they be conscious beings with their own experiences?
That's a question that Tippler really grapples with, and he argues that a sufficiently detailed simulation would be indistinguishable from the original person, down to the atomic level. And if we can't tell the difference, then for all practical purposes, they are the same person.
So our digital ghosts, in a way, are living in some super advanced computer simulation,
right,
long after our physical bodies are gone, and not just existing, but potentially continuing to learn, grow, experience new things.
Yes.
I mean, it really makes you wonder about the nature of identity and consciousness.
It really does. It kind of challenges those conventional notions of what it means to be alive and to have a self.
Yeah. So eternal progress for civilizations,
right,
and a chance at digital immortality for individuals. It's a grand vision, an optimistic vision of the universe. But let's be real here. Isn't it all just wild speculation at this point?
It is. It's important to remember that the omega point theory is just one interpretation of the strong anthropic principle. And a lot of scientists and philosophers, they find it, highly controversial, even implausible.
So what are some of the main criticisms of the theory?
Well, one of the biggest hurdles is the lack of evidence. We have no observational data to support the existence of this omega point or this convergence of all world lines.
Right.
Furthermore, the theory really relies heavily on future developments in physics. It's essentially extrapolating far beyond our current knowledge.
So it's like trying to predict the future of technology based on our understanding of like 19th century physics.
Right, exactly.
You might be able to envision some possibilities, but the actual future could be vastly different.
Exactly. But here's the thing. Tippler does make some testable predictions, even if they, seem far-fetched at the moment.
Okay, what kind of predictions?
For example, he predicts that the universe must be closed, not open or flat, as we discussed earlier.
Right.
He also predicts that the future sea boundary must consist of a single point, the omega point.
Okay.
And he makes specific predictions about the density of particle states, which is a measure of the number of possible states that a particle can occupy at a given energy level.
So even if the omega point theory is a long shot, it's not completely ruled out.
Wow.
Future observations, experiments could potentially support or refute these predictions.
Yeah.
So I guess that leaves the door open for more speculation.
It does, but even if the omega point theory is ultimately proven wrong, I think it serves as this powerful reminder of the the vastness of the unknown and the limitations of our current understanding.
Okay.
And it encourages us to kind of think beyond the confines of our current knowledge and to embrace the possibility that the universe might be far stranger and more wondrous than we can even imagine.
Well said. And I think that's a great place to wrap up our deep dive into the anthropic principle. We've explored some truly mind-bending concepts.
We have.
From the idea that our very existence shapes our perception of the universe, to the possibility that the universe is evolving towards this final state of ultimate intelligence.
Yeah.
We've encountered breathtaking possibilities,
Yeah.
unsettling paradoxes, and really profound questions about the nature of reality itself.
It's been an exhilarating journey.
It has.
And we encourage our listeners to continue exploring these ideas, to delve deeper into the works of thinkers like Frank Tipler, John Barrow, Roger Penrose.
Yes.
Their writings really offer this glimpse into a universe that's far more complex and fascinating than we might ever have imagined.
And remember, even if some of these theories seem far-fetched,
right,
or even impossible, they challenge us to expand our thinking.
Absolutely.
To question our assumptions.
Yeah.
And to really embrace the mystery and the wonder that lie at the heart of our existence.
Beautifully put. Until next time, keep questioning, keep exploring.
Keep wondering.
And keep wondering about your place in this extraordinary cosmos.
Absolutely.